Coming to your 8086 functional units. As I told you, it has two functional units, execution unit and bus interface unit. Let us go to execution unit. The execution unit give instructions to bus interface unit as to how to fetch the data, where to fetch the data, then you have to read the data and execute these instructions. So it is one kind of where it gives instruction. The bus interface unit cannot work on its own. So execution unit has to give instructions to bus interface unit. It has to give directions like how to fetch the data, read, that is decode, and execute it. Its function is to control the operations using the instruction decoder and address latch enable. Execution unit has no direct connection with the system buses as shown in the diagram. I can go back to the diagram here. See here, execution unit has no connection here. It is separate. The buses are directly, the system buses are here itself. Now let us go to your bus interface unit, where you are going to have is your ALU, arithmetic and logic unit. As name suggests, it handles all arithmetic and logical operations like plus, minus, multiplication, division, or and not operations. Flag register, just like your 8085, 8086 microprocessor also has a flag register where it's a 16-bit register that behaves like a flip-flop. That is, it changes its status according to the result stored in the accumulator. So whatever the output you get as a result of your arithmetic operation, the kind of an output will going to influence your flag register. So the flag register is not as simple as in 8085. Rather, it is divided into two groups, that is conditional flags and control flags. Let us see one by one. Conditional flags. This represents the result of the last arithmetic and logical instruction executed. But that is, whatever the latest arithmetic or logical instruction is being executed, these flags will get updated. The following are your conditional flags: carry flag, auxiliary carry flag, parity flag, zero flag, sign flag, and overflow flag. Let us see the first one, carry flag. This flag is an indication of an overflow condition for an arithmetic operations. The word itself, overflow, means, for example, let's take a simple example. You are filling the bucket with water. Tap full of bucket, you are going to fill the water. And up to a certain point, the bucket has certain capacity, so it can hold the water. Above which, what will happen is the water starts overflowing. Like that similar condition, like every data or every value, every register will have certain limit to which it can hold the data, beyond which it overflows. This is what the carry flag. Auxiliary carry flag. See, suppose you take a value. Suppose you are going to perform an arithmetic operation of an 8-bit number. That entire 8-bit is divided into lower nibble and upper nibble. That is, from D0 to D7, that is 8-bit, is divided into D0 to D3 and D4 to D7. So whenever there is an operation of carry or borrow from the lower nibble to upper nibble, this particular flag is set. That is, the carry occurs as a result of a bit from D3 to D4. This is your auxiliary carry flag or auxiliary flag, whatever the name. The notations are different, the function is same. This processor uses this flag to perform this binary to BCD conversion. There are certain flags like parity flag. This records the parity, that is, whenever you get the answer, that is, even number of ones are there. In a 8-bit, if the number of ones are even, means the count of ones are even, means even parity is set. Otherwise, if the count of ones is odd, means odd parity is set. Zero flag. This condition is set when the entire result of an arithmetic operation is 0. Means this set is 1, set to 1. Otherwise, it is 0. Sign flag. For a new operation, suppose you are going to find the result. If the given result is a positive number or negative number, this flag holds true. If the given result is negative, means sign flag is set to 1. Otherwise, it is 0. Overflow flag. This is a result. This flag represents the result when the system capacity is exceeded, the overall capacity. There should be one thing here. The carry flag and the overflow flag have a similar kind of a nature, but they have a different functionality. Carry flag is just an arithmetic condition. A result due to arithmetic condition only when extra bit comes, whereas overflow is overall system capacity becomes more. Now coming to the next set of flags, that is your control flags. The control flags control the operations of the execution unit. The following are the list of control flags: trap flag, interrupt flag, direction flag. Trap flag is meant for one time executing one set of instructions at a time. Interrupt flag is nothing but any interrupt operation is occurring in the microprocessor where any peripheral or any device wants to have an attention of the processor, means this flag is set. Direction is for whether the string accessing, that is, you are going to have a string of data, how it is accessing from lower address to higher memory address or higher memory address to lower memory address. This is set. This is the case of your direction flag. Now coming to the main general purpose registers which will be used always in 8086 arithmetic operations. There are 8 general purpose registers: AH, AL, BH, BL, CH, CL, DH and DL. See, they are basically AH means higher end, AL means lower end. If you put it collectively together, they become AX, BX, CX and DX. They are basically 16-bit registers, but they can also be used individually to store 8-bit data. AX is accumulator register, just like your 8085. It is used to store operands for arithmetic operations. BX, base register. Like this, you can use transfer the data between your accumulator register and base, this register, which is used to store the base address of the memory area. CX register is used as a counter, basically used for loop instruction. DX register is meant for holding input-output port address for input-output instruction. Stack pointer register. This is similar to what you had a stack pointer register in 8085, which holds the address of the address from the start of the segment to the memory location, where the recent data which is being used is stored in the stack. It's a kind of a RAM. Now coming to bus interface unit. This takes care of all data and address transfers on the buses for the EU, like fetching instructions from the memory, reading the data from the ports memory, as well as writing the data to the ports. EU has no direct connection with the system buses, so through bus interface unit they are connected with the system buses. Both EU and BIU have connected with internal buses. It has got certain functional parts. Instruction queue. As I told you, instruction queue is nothing but like where you are going to store the data one after another. So 6 bytes of instructions they are stored in instruction queue. BIU contains the instruction queue, EU executes this instruction. One instruction is executed, it's ready for the next instruction. So like that it goes on. And as I told you, fetching the next instruction while the current instruction is being executed is called as pipelining. This is one feature which is not at all there in 8085. Now coming to the next set of registers, that is your segment register. BIU has 4 segment buses: code segment, data segment, stack segment, extra segment. They hold addresses of instructions and data in memory. So they are going to used by the processor to access memory locations. So the memory locations are accessed with the help of addresses which are present in this registers. So there is nothing important here, rather you can say code segment stands for code segment register, which is used for addressing a memory location where program is stored. Data segment consists of addresses where of the data which are being used by the program. Stack segment meant for memory to store the data and addresses. Extra segment, extra additional data which is going to be used by the string. An instruction pointer is nothing but your register which is used to hold the address of the next instruction to be executed. It's rather similar to what you have instruction pointer in 8085. Thank you for that.